Hi, my name is Alex Steinmaurer and I'm a university assistant and PhD student at Graz University of Technology in Austria. My research focuses on computer science education, engaging learning technologies, and computational thinking. Together with my colleagues Anne Tilante and Christian Güttl, we worked on the following project related to a learning analytics platform for our coding learning game sCool. The motivation behind this project is that learning to program can be hard for beginners. Many game-based approaches exist in schools and universities to make this easier. These tools also help to identify students' learning progress by collecting data, doing code review, or pair programming. This data is used for individual feedback, for teachers, and also for the students as well. The sCool environment is a flexible game which contains of a web platform for educators and a video game for students. The students learn computer science concepts based on an engaging story and gameplay by helping a space crew to escape a hostile planet. All game data, such as past levels, provided source code, or game durations are sent to a REST web service and then stored in a MySQL database. We mainly identified 4 requirements for a learning analytics platform, based on previous research and of course related work. First, the system should provide basic statistics such as calculating means, median, min values, max values, and so on. Since a learning experience can compromise more school lessons, time series and Gantt charts with the progress should be also provided. Due to various types of data, the system should provide interactive data visualizations with different chart types such as scatter plots or bar charts. And finally, the system should assist in identifying the learning process while learning to program. The Learning Analytics tool is mainly written in Python and the open source graphic library Plotly. The system uses data from the sCool MySQL database for learning analytics. The interface consists of 4 main areas, which can be seen on the left side of this view: Group Overview, Details for certain groups, Students Views, and Custom Visualizations. A quite relevant concept are so-called learning activities, which educators can create. Such an activity can be one or more school lessons related to a specific topic. The teachers can analyze their own learning their learning activities individually or compare them with other groups to make comparisons between more groups or even classes. The Details section contains specific information about a learning activity, such as task information, information about programming concepts, or game metrics, such as points or rewards. The Students view gives an overview about the learning progress of a certain player within the sCool game environment. Educators can receive information such as applied programming concepts, lines of code that were written in a specific task or in general, or the duration of a session. It is also possible to see how many points were collected, how many items were counted, and also where in the game, so in which task, the players currently are. The Custom section allows educators and teachers to create own visualizations and analysis based on different features such as attempts, skills, tasks, or other features that are relevant within the learning game. They can select different types of plots such as bar charts, scatter plots, line, or tables. They can also export the data as CSV files or in any other format which is convenient for further analysis. Within the scope of this project, we defined 3 research objectives which were observed. The first objective is, does the platform support all requirements teachers have in a learning analytics tool? Within the second objective, we wanted to analyze if teachers can use the system to analyze the students' individual and group-wise learning process. As a third research objective, we want to figure out if there are some major usability issues. We conducted 2 studies. one as a usability evaluation and the second one with domain experts. Within the usability evaluation, we reached out to a group of 60 to 80 people, which were provided with a link to the evaluation. 31 participants respond to this evaluation. They are strongly related to a computer science background. They were provided with a link with all further instructions and a questionnaire. In total, 11 tasks within the tool should be solved. First, they were provided with an introductory video about the learning platform. In the next step, they had to solve 11 tasks, which were assigned to 5 categories based on the specific type of each task. After each group, they were also asked to answer the sCool questionnaire. At the end of the questionnaire, they also answered the system usability scale to get some overall idea about usability. The second evaluation was conducted with domain experts, to be more precise, with a group of 8 computer science teachers. They were given 5 tasks within the learning analytics platform, which were highly related to specific programming tasks within the sCool game environment. Since teachers were already familiar with the sCool environment, they could optionally watch a video about the game. After this, they answered a questionnaire containing 4 parts. First, demographics and professional related questions such as the job experience and so on. After this, they were asked about experience with learning analytics tools in general. After answering these pre-questions, they had to solve 5 tasks in the learning analytics tool and provide the right answers and rate each task in terms of its level of difficulty. Finally, they received some questions about the system and its usage and usability. The results of the usability evaluation shows that the system is high above average, which means that the system usability scale score is above 68. In this chart, all 31 participants are listed. We also performed an outlier detection by standard deviation method and identified 3 outliers, which are gray within the bar chart. The sCool score showed that the workload is perceived as low to moderate. Despite these promising results, the domain experts evaluation showed that there are still some usability issues when performing specific evaluations. The results of the analysis and data visualization showed that teachers are interested in a learner-oriented system. It is hard to find a balance between the system's complexity and possibilities within the learning analytics tool. The participants had issues with receiving specific information on the system. The study also showed that the system provides more possibilities to perform a certain analysis to get ambiguous results. Based on the results, we identified 4 aspects that are relevant for a learning platform. First, the system should be well structured and easy to use with a flat hierarchy. All data should be provided as simple as possible. Next, the system should have a good balance between comprehensive data analysis and an intuitive and easy usage. Mechanisms such as interactive onboarding can help to navigate through a tool. The platform should also provide a transparent perspective on the learning progress for both teachers and students. It should also support teachers in grading. And finally, teachers are highly concerned about their students' privacy. All data should be highly protected by using encryption or, for example, pseudonyms within a game environment. For future research, we plan to include players also in the learning analytics tool to make the learning process as transparent as possible. Based on the results of both studies, we plan to make some improvements in the system usability. In the next step, we will also run evaluation with a larger group of participants and track the user interaction with a specific web analytics service. Thank you for your attention.